Hello everybody. Today I want to move on and talk about the second kind of bonding. The second kind of bonding that we need to talk about is called covalent bonding. So far we have already talked about a kind of bonding called ionic bonding. An ionic bond is always between a metal and a non-metal. That is why when we looked on the periodic table and we look at these, we always have a metal bonding to a non-metal. So we have one of these many elements that are in color right now bonding to one of these elements that are now in color. That is an ionic bond. We then added that ions can be polyatomic. We can have a lot of atoms bonding to each other to form an ion, but it still works the same way. Today, we need to talk about what's called a covalent bond. A covalent bond is always between two non-metals. But the nice thing about this, going back to the periodic table, the nice thing about covalent bonds and the fact that they're going to be forming a bond is the fact that we once again go back to the octet rule. So we are doing the octet rule, and now it is more important than ever. I mentioned it in ionic bonds, but now we really need to talk about the octet rule. In an ionic bond, it's a metal and a non-metal, and it's a transfer of electrons. In a covalent bond, instead of a transfer, the electrons are shared. Another way to think about this would be like they're holding hands. Each atom has a hand out, and when they hold hands, that forms a bond that actually holds it together. So once again, back to the periodic table, we are only talking about nonmetals here. And in order to make atoms happy and have them share electrons, we want them to share them so that they actually have 8 after they share with other atoms. Well, the cool thing about this is noble gases already have 8, and helium has its 2, so it has a full outer energy level. We do not need to worry about the noble gases here at all. So when we say it's between nonmetals, really what we're saying is it's between nonmetals that aren't noble gases. And if we count those, we're talking hydrogen, carbon, nitrogen, oxygen, fluorine, phosphorus, sulfur, chlorine, selenium, bromine, iodine, astatine, and unseptium. We are not talking about a lot of atoms. Now, we've talked about metalloids and the fact that they can act like a metal or a non-metal. Well, that's going to affect what kind of bond they make. If they're acting like a metal, if they bond to a non-metal, it would be an ionic bond. But if they act like a non-metal bonding to another non-metal, it will be a covalent bond. So we do have to include the metalloids, but if we are only talking about the metalloids, the other nonmetals, and the halogens, these are the only atoms we are even talking about. We need to once again review that if we are talking valence electrons, if we're talking about these, then we are saying hydrogen starts with 1, boron being the only metalloid that we need to worry about is 3, carbon and anything below it 4, 5, 6, 7, and we don't need to worry about the noble gases because they already are happy and aren't going to bond. So if you look at a periodic table, you need to be able to say hydrogen has 1 valence electron, boron has 3, carbon has 4. You need to be able to see how many valence electrons they start with. With that said, I will then just start doing some examples. What we do here is we have to know, we are going to draw what is called a Lewis dot structure. Dot being the electrons. And you may Google this and you may find people have done videos on electron dot structures, electron dot diagrams. They're called all sorts of things. I always call them Lewis dot structures. We're going to do a Lewis dot structure for H2. That means there are two hydrogens bonded together. Two hydrogens. They're both nonmetals. What we do here is we want to know how many valence electrons do those have. We have two hydrogens. We just said by going back and looking at the periodic table, hydrogen has one valence electron. So when we add those up, each one has one. That means they have a total of 2 electrons. So what we do is we draw a hydrogen with one valence electron, another hydrogen with another valence electron, and electrons like to be in pairs. So now instead of 2 dots, we draw this as a dash to represent that this is now a shared bond. Electrons by themselves are only on the atom that we are discussing. Or if they are drawn as dots, those dots only count on the particular atom. But if we draw it as a dash, we are drawing 2 dots, but now we're saying those are shared. You may be looking at this and saying, well, how is that the Lewis dot structure? It doesn't have 8. What it does have is 2. That hydrogen now has 2 around it, and because of sharing, this hydrogen has 2 around it. Those 2 electrons are shared. That hydrogen now has 2, that hydrogen has 2. That's not the octet rule. Well, here's the first exception to the octet rule. Hydrogen, because its outer energy level can only hold 2, because it's a small atom, it only needs 2. The next one I quickly want to show you is HCl. Hydrogen, chlorine. So if it helps you, write that you have a hydrogen, 1, and chlorine, 1. You have 1 of each. Well, how many valence electrons does hydrogen have? We already saw that it has 1. Then, how many valence electrons does chlorine have? Well, let's find chlorine. Chlorine is right here. It is in the column that has 7 valence electrons. So, we know it has 7. That means our entire picture is going to have 8 dots. It's a beautiful thing when you see 8, because you know, because of the octet rule, that we're already in really good shape. So we're going to draw a hydrogen with 1 valence electron. Then we're going to draw a chlorine, 1, 2, 3, 4, 5, 6, 7. I hope you see what 2 electrons are going to be shared to form a bond. And it is these 2. Because now, if we look at how many atoms each, or how many electrons each atom has, hydrogen is happy, it has 2. Chlorine is now happy because it currently has 8 electrons around it. 1, and I'll redraw them, 1, 2, 3, 4, 5, 6, 7, 8. And going back to what I said just a moment ago, if it's drawn as a dash, those are shared, and both atoms have it. So these 2 belong to the hydrogen and the chlorine now because they're shared. But these sets of dots, 2, 4, 6, only belong to the chlorine because chlorine isn't sharing everything there. Alright? The 2 I've just done are the 2 that are currently on your homework. So I just did H2 and HCl. Let's do one more because it's the all-important atom that we all should know and love, or the compound, the molecule of water. H. Each hydrogen has one valence electron, an H there and an H there. I have 2 hydrogens. I know that because of that 2. I have 1 oxygen because O. We don't write ones behind it. So 2 hydrogens and an oxygen. 1 plus 1, oxygen is, can't go back to the periodic table, but if you look at 1, oxygen is in the 16th column. It has 6 valence electrons. Looky there, look how many total dots we have. I don't ever want to start with hydrogen. I want to start with oxygen because it doesn't have 8, and we know it needs some. So I'm going to start and put an oxygen right here. I'm then going to put 6 dots around it. 1, 2, 3, 4. Because I know what's coming, I'm going to put 5 there and 6 there. Alright, we now need to put a hydrogen with 1 dot. Let's change colors to show this. I need to put hydrogen with 1 dot in a place so when it shares, it has 2. I hope you're screaming at me, put it right there. That's a really good idea, because that now forms a bond. If I then switch colors, and let's go and use black, if I put the other hydrogen right here, that now forms a bond. And now only using green, I hope you see that that hydrogen has 2, it's happy, that hydrogen has 2, and the oxygen has 8 around it. 1, 2, 3, 4, 5, 6, 7, 8. Dashes are shared, 2 electrons shared, and dots by themselves, but they still pair up, are only counted on the atom that they're next to. So that entire picture has 8 electrons. The hydrogens are happy with 2, and the oxygen is happy with 8. Continue on. I would like you to do the front tonight. Try to do the front in the next 10 minutes and then call it an evening. We will do the rest of the front and the back tomorrow and do as many of these as we possibly can. Thank you very much, and I will see you tomorrow.